Imagine you're playing quantum Russian roulette. The only version of you that survives is the one that was lucky enough to be in the branch where you didn't die every single time. You should take that as good evidence that the many worlds interpretation of quantum mechanics is correct.
For decades, scientists have been searching for the theory of everything, the ultimate framework that could unify all of physics into a single coherent model. This theory aims to bridge the gap between Einstein's general relativity, which explains gravity and the motion of massive objects, and quantum mechanics, which governs the strange behavior of particles at the smallest scales. While both theories have been extensively tested in their respective domains, they contradict each other when applied together. This fundamental conflict has left physicists searching for a missing link that would unify the macro and micro scales of the universe under a single set of laws. Various attempts, including string theory, have tried to solve this puzzle, but none have fully succeeded in explaining how the universe truly works at every level. Now, a new player has entered the game, Google's Sycamore quantum processor. Unlike classical computers, which process information using binary code, strictly zeros and ones, quantum computers operate using qubits, which can exist in multiple states at once. This allows them to perform calculations far beyond the reach of traditional systems, opening doors to uncharted territories in physics. Recently, Google's Sycamore chip executed a series of groundbreaking experiments that produced unexpected results, hinting at physics beyond the standard model, the current framework that describes the known fundamental forces and particles in the universe. If these findings hold up, they could indicate a fundamental shift in our understanding of reality itself. In a recent experiment, researchers tasked Sycamore with running a complex quantum simulation designed to analyze particle interactions at a fundamental level. The goal was to test known quantum principles, but the results contradicted established quantum mechanics. Certain particles behaved in ways that shouldn't be possible under our current understanding of physics. Despite its bizarre nature, quantum mechanics is extremely precise, predicting probabilities and particle states with near-perfect accuracy. Yet Google's experiment produced anomalies that defied these rules entirely. Some scientists speculate that these results may point to a hidden layer of reality that classical physics has never been able to detect. If true, this could mean our current model of physics is incomplete and that a deeper set of laws governs the universe at the most fundamental level. Dr. John Preskill, a leading expert in quantum physics, has described Google's advancements as a window into a new reality. He believes these experiments are not just technological breakthroughs but potential paradigm shifts in our understanding of the universe. Theoretical physicist Michio Kaku has suggested that quantum computers might hold the key to unlocking dimensions beyond our perception, a concept that has been purely theoretical until now. If these anomalies are real, Sycamore may have taken the first experimental step toward proving the existence of parallel realities. Google's quantum experiment didn't just reveal an anomaly, it may have uncovered a completely new force of nature, something beyond the four fundamental forces that currently govern the universe: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. For decades, physicists have speculated about a hidden force operating at the quantum level that could explain the missing link between general relativity and quantum mechanics. Now, the data from Google's Sycamore processor suggests this force might actually exist. The strange particle behaviors observed in the experiment didn't match any known interactions, leading some experts to believe that Sycamore may have detected a fifth force of nature. If confirmed, this discovery could be the first step toward proving quantum gravity, the long-sought theory that would finally unite Einstein's laws of gravity with the unpredictable world of quantum mechanics. To put this into perspective, this potential discovery is being compared to Einstein's breakthrough on relativity and the Higgs boson discovery in 2012, both of which transformed modern physics. If Google's findings hold up, this could be an even bigger paradigm shift, fundamentally rewriting the laws of the universe. Scientists around the world are now racing to replicate Google's results. If independent experiments confirm this data, it could lead to a complete overhaul of modern physics textbooks, requiring us to rethink everything we thought we knew about the universe. However, the most shocking part came when Google's team ran the experiment again. In classical physics, repeating an experiment under the same conditions should yield the same results. But what happened next left physicists even more baffled. Google's quantum chip produced two completely different outcomes for the same experiment. The laws of classical physics say this shouldn't be possible, yet the data clearly showed that the system behaved one way in the first test and in a completely different way in the second. It was as if the quantum system was responding to something beyond our reality, suggesting that the universe itself might be probabilistic at a fundamental level. Quantum mechanics already hints at this with the idea of wave-function collapse, where a particle's state isn't decided until it's observed. But this experiment took things a step further. What if the universe isn't just probabilistic but actually exists in multiple states simultaneously? Some physicists speculate that these inconsistent results could be evidence of parallel realities interacting with each other, where each outcome belongs to a different timeline. For decades, the multiverse theory has remained one of the most controversial ideas in physics, supported by quantum mechanics but lacking direct experimental proof. Now, Google's quantum chip may have provided the first real-world evidence that parallel universes exist. This idea aligns with several prominent quantum theories, including the many worlds interpretation, which suggests that every quantum event creates a branching timeline, leading to an infinite number of realities where different versions of events play out. If Sycamore's processor is interacting with multiple quantum states at once, it could mean that Google's machine isn't just calculating probabilities, it's accessing parallel timelines in real time. One of the most shocking pieces of supporting evidence comes from NASA scientist Dr. James Gates, who has pointed out strange mathematical structures embedded in the fundamental equations of physics, structures that resemble computer code. If reality itself contains coded patterns, it raises an unsettling question: are we living in a simulation? Could this experiment be the first hint that our universe is a form of cosmic computation interacting with other simulated realities? Physicists now have more questions than answers. If Google's quantum chip is indeed tapping into the multiverse, it challenges everything we thought we knew about the nature of existence. The implications of Google's experiment have sent shockwaves through the scientific community. If what their quantum processor observed is real, it could completely redefine physics and open up possibilities that were once confined to science fiction. Right now, physicists around the world are rushing to verify Google's findings. Replication is a key step in science. If independent teams can reproduce these anomalies under controlled conditions, it would confirm that what happened wasn't just a glitch but a real interaction with quantum reality itself. Some researchers are already designing new quantum experiments to test whether these results hold up under different conditions, while others are exploring whether these fluctuations could be manipulated intentionally. If we learn how to control these interactions, it could lead to the biggest technological revolution in human history. This potential has caught the attention of governments and private institutions, which are now investing billions in quantum computing. Organizations like NASA, the US Department of Defense, and major tech companies have ramped up funding for quantum research. Some believe that whoever controls quantum computing will control the future, not just in science but in national security, artificial intelligence, and even space travel. If validated, this discovery could usher in a new era of quantum science, leading to groundbreaking developments such as quantum-powered AI, time manipulation, and even interdimensional travel. These discoveries won't just impact scientists in labs. A true understanding of quantum mechanics could unlock next-generation computing, medical breakthroughs, and even new methods of space travel. If Google's findings are verified, we might have just found the first experimental evidence that the multiverse is real. But as always, more research is needed before we can draw final conclusions. What we do know is that we are on the brink of something enormous, a discovery that could reshape the very fabric of reality. This might just be the beginning.